You've put in the years of study and earned your engineering degree, but the job offers aren't appearing as quickly as you expected. In a classroom, you learn the equations and the theory. On a factory floor, you encounter a different language, a practical way that machines interact that isn't always covered in a textbook. Manufacturing, energy, and chemical plants all rely on industrial automation, and they seek engineers who understand how these systems function in the real world. Consider a basic physical challenge: how a tiny low-power computer chip on a control board manages to move a heavy iron valve out in the plant. Understanding how these machines communicate and exert force is a primary factor in moving from an entry-level applicant to a specialized professional. This diagram shows the brain of the factory, the PLC. This controller makes the decisions, but it communicates using low-voltage electrical signals. This specific electrical signal stays within a precise range of 4 to 20 milliamps. On the other side of the floor is the muscle, the pneumatic control valve. It doesn't run on electricity. It requires the physical push of compressed air to open and close. Because electricity cannot move the heavy valve directly, we place an I to P, or current to pressure, converter between them. It acts as the bridge between the electronics and the air pressure. Without this device, the signals from the brain would have no way to physically move the heavy equipment out in the plant. To understand how this translation works, think about pressing your thumb over the end of a running garden hose. By blocking the opening, the water cannot escape as easily, and the pressure builds up immediately behind your thumb. This is the exact principle used inside the converter, involving a mechanism called the flapper nozzle. Inside the device, air flows out of a small pipe called the nozzle. A metal plate called the flapper sits just above it. At the moment, the air is escaping freely around the edges of that plate. When the 4 to 20 milliamp signal arrives from the controller, it powers an electromagnet located right above that flapper. The magnet pulls the flapper down toward the nozzle. This limits the amount of air that can get out, much like your thumb on the hose. As the air is restricted, the pressure inside the line builds up. This creates the 3 to 15 psi needed to operate the heavy valve. The converter uses magnetic force to control the air supply, turning electrical commands into physical movement. In a massive chemical storage facility, these I to P converters are used to precisely adjust the valves on large tanks. Using compressed air instead of high-voltage electricity in these environments helps maintain safety near flammable materials. Hiring managers look for engineers who can apply these principles to solve real-world safety and operational challenges. Engineers with this applied knowledge are the ones who step into modern control rooms and secure high-level careers. You can start building this applied knowledge at the Coach Manmeet Singh Bhatti website. Sign up for the upcoming free webinar. These sessions fill up quickly and provide a roadmap for becoming industry-ready. Success in modern engineering is built on mastering the practical tools that keep these industries running.